This transparent steam iron labeled origin iron shows exactly how the appliance most people use every day actually works inside. The main principle is simple. Wrinkles are removed with heat and pressure, and steam makes the job easier by relaxing the fibers of the fabric before the hot surface presses them flat. The process starts in the water tank near the handle, which is marked with a CHO in the diagram. You fill it with distilled or filtered water, usually around 200–350 milliliters. From there, water travels through a small tube toward the heating chamber. The iron doesn't just heat the bottom plate directly, it also converts that water into steam. And that's where the orange coil visible in the image comes in. That coil is the heating element, usually made of nichrome wire. When electricity flows through it, the resistance generates intense heat. This one coil does two jobs at once. It heats the soleplate, the metal base that touches the clothes, and it superheats the water inside the steam generator chamber, turning it instantly into steam at well above 100 degrees Celsius. The thermostat, labeled in the diagram spelled as rheostats, controls the temperature. It's connected to the dial you turn for cotton, silk, wool, etc. Inside it's usually a bimetallic strip to different metals bonded together that bend at different rates when heated. Once the soleplate reaches the set temperature, the strip bends enough to break the circuit and cut power to the heating element. When it cools a bit, it reconnects and heating resumes. That's why the indicator light on an iron keeps blinking on and off while you work. Once steam is produced in the generator, it travels through internal channels to the soleplate vents, the small holes on the bottom of the iron. The diagram shows white steam pouring out of these vents onto the blue striped shirt underneath. That steam penetrates the fabric, loosens the bonds between the fibers, and makes the cloth soft and pliable. Then the weight and heat of the soleplate press those relaxed fibers flat, and when the fabric cools a few seconds later, the wrinkles stay gone. The soleplate itself is usually stainless steel, ceramic coated or Teflon coated so it glides smoothly and doesn't stick to or scorch the cloth. The vents are spread across the surface to distribute steam evenly, which is especially useful on heavy fabrics like cotton or linen where a dry iron would take much longer. Compared to a dry iron, the steam function saves time and reduces the risk of burning because you don't have to press as hard. The moisture does half the work. That's why shirt collars, sleeves, and pleats come out crisp with less effort. The trade-off is maintenance. You must use clean water to avoid mineral buildups killing inside the tank and steam chamber. And you should empty leftover water after use to prevent corrosion. What this see-through model makes clear is how compact and coordinated the system is. Electricity flows into the heating coil. The thermostat cycles it on and off to hold temperature. A few drops of water flash to steam, and that steam is forced out through vents right where the hot metal meets the fabric. Every part, tank, thermostat, coil, generator, vents, soleplate works together in a closed loop. It's a small example of applied physics and engineering sitting on the ironing board, turning electricity and water into smooth, pressed clothes in minutes.